why don't you give, for those that aren't familiar with vast data, give us the the elevator
Sure.
pitch
The
and so on.
the really short form on vast data is that we make very large scale all flash file and object storage systems. And when I say very large scale, our average selling price for a cluster is well on the north side of $1 million. It's multiple petabytes. Today, we're just introducing a new storage enclosure that brings our building block down from 675 terabytes per HA enclosure to 338. So we're taking it down by a factor of two. We're going from a 2U to a 1U enclosure. We'll talk about that in a little bit. But the innovative thing about VAST is the architecture. If you talk about a large scale system like we build, traditionally that's been done with a scale out shared nothing model where you have a lot of x86 servers. Each of those x86 servers owns some set of media and they communicate on a back end network, and software makes it look like one big system.
Right.
But those systems start to break down at really large scale. And so we've come up with a new model we call DACE, the Disaggregated Shared Everything Architecture. Instead of having a field of peer nodes, each of which owns some media, we disaggregated the media into these HA enclosures that I was just talking about. So no single point of failure, 400 gig connections to an NVMe fabric. And that's typically 100 gig Ethernet. Some of our HPC customers like to run InfiniBand, so we can do InfiniBand as well. All those enclosures do is hold data. There's no services there. All of the services, everything that you would think of as the controller function of the system, runs in stateless Docker containers in the front end servers. So when a user makes a request to a protocol server, to one of those front end servers, could be NFS, could be SMB, could be S3, that server looks in the metadata that's stored in storage class memory in the enclosures, finds the data the user's requesting in the data in QLC Flash in those same enclosures, retrieves it over the NVMe over Fabric's fabric, and delivers it to the user. So there's none of the traffic from node to node required to reassemble data. Everything's north-south across that NVMe over Fabrics connection. And since the metadata is in storage class memory, it's fast enough to directly access by all of the front end servers that they can just share it. They don't have to cache it. And by
So,
not having the cache, we don't have all the complexities of keeping the cache coherent.
Could restore